जरूरी ये चीज ये चीज तो मेरे साथ बहुत हुई थी फर्स्ट राउंड में, मतलब गंदा हो रहा था मेरा तो इन्हीं के कारण, एक एक चीज में घुमाया जा रहा था मेरे वजह से। मैं घुमा रहा था उससे, मतलब मैं हर एक चीज का एक ही आंसर दे रहा था, वो चाह कुछ और रहा था, इसलिए मेरा बिगड़ गया था पहला।
Discussed and the most interesting thing
हाँ मतलब ये तो है, जैसे अब नेक्स्ट
So, guys, let's continue with the next part. My plan is to start a very new topic today. Multiple topics we have done, we have discussed, and the most interesting thing is it is not about the done and discussed. It is about how how we integrate those things to solve some use cases, right? So we have one more topic that is very very interesting, very powerful, and we would like to start the thing from there, right? So today I would like to start a topic called ELK. Right, so this is the new topic for today. Multiple different use case this topic gonna solve for us. Okay, so what is ELK? We will discuss in detail. But by the meantime, to save our time, I'm launching my instance so we can jump to the practical or to the hands-on. Okay, so let me explain you the first use case, right? Then we will discuss about where the ELK fit. So you can think in this way. Guys, the power of data, right? You know the power of data. Okay, so it is something like this. If I take the same example again, let's say this is your web server, and on the top of the web server, let me clean my screen. Let me write from the scratch. So let's say in this way, we have a web server, and guys, on the top of web server, we launch the web app. Okay, and web server is just the one who run this app. Okay, and obviously web server run on the top of the operating system, and operating system is running on the top of your physical hardware. Okay, and now we have multiple clients on the internet actually. Okay, and when a client hit to the application,
screen now visible? For some, it is visible. I think it's issue at your end.
So, guys, let's continue with the next part. My plan is to start a very new topic today. Multiple topics we have done, we have discussed, and the most interesting thing is it is not about the done and discussed. It is about how how we integrate those things to solve some use cases, right? So we have one more topic that is very very interesting, very powerful, and we would like to start the thing from there, right? So today I would like to start a topic called ELK. Right, so this is the new topic for today. Multiple different use case this topic gonna solve for us. Okay, so what is ELK? We will discuss in detail. But by the meantime, to save our time, I'm launching my instance so we can jump to the practical or to the hands-on. Okay, so let me explain you the first use case, right? Then we will discuss about where the ELK fit. So you can think in this way. Guys, the power of data, right? You know the power of data. Okay, so it is something like this. If I take the same example again, let's say this is your web server, and on the top of the web server, let me clean my screen. Let me write from the scratch. So let's say in this way, we have a web server, and guys, on the top of web server we launch the web app. Okay, and web server is just the one who run this app. Okay, and obviously web server run on the top of the operating system, and operating system is running on the top of your physical hardware. Okay, and now we have multiple clients on the internet actually. Okay, and when a client hit to the application. Okay, so technically they don't hit directly to the application, right? A client always connect to the web server, let's say Apache web server. And Apache web server is the one who behind the scene go run your code, okay, and get the output and give it to the clients. This is the way it works. And that is a reason that is in this application, if you create in PHP and Python, they are known as server side language, because server is the one who run this rather than the client run. Client always get the output, that's all. Okay, but in this context, because your client is going always via server, so server record this information. Okay, and they record this information, means they store this data somewhere in some file. Okay, and what they store, information at what time a client come, from which IP they come, for which file they come, and some other information. Those information or the data we collect, and after we collect, we store in one file. And file is normally in one storage, one hard disk, maybe in some cloud storage, maybe in NFS storage, whatever you guys know, they store it. And typically these records, you guys know, it is not a log. But intention guy here is this part, I think multiple times I talked you about this part. Even though if you guys was part of my Sunday training, I see there also I discussed this part. Okay, but if you see here, okay, we collect a log, or we collect information and store in a file on the storage. Why we collect? Okay, one of the reason is to collect is to analyze. Okay, so this would be my older information. This is called historical. Okay, so this is my history. In the future, I just want to go and check what happened from last 1 year or 1 month and something like this. So we store information, right, about what is happening right now. So in the future, we can analyze, we can audit, and something is not working that time, and I just want to see after 1 hour why somebody from which IP some client is coming, or they are hitting, or they are breaking the system. So from this log, we can audit, we can troubleshoot, we can analyze multiple things we can do. Okay, so this part you guys know, and that is a reason that is a reason because we always need analysis, and more than analysis, the important thing is about the auditing, right? Or one of the example is of auditing you can consider, right? Maybe let's say some client, or is not a client, is a cracker. He tried to do the DOS attack, or try to give multiple wrong password attempt to break some of the account, or maybe he got the access. So if you have a record, if you have the log that you have collected from the web server and store somewhere, because store server means permanent, or because permanent, so in the future we can audit and we can see the log, and we can try to find the cause behind or why this low, or maybe we can find from where they attacked, right? So almost all the reason we need a log to be stored permanent. Okay, but there's one more thing here. Is something that is keep on changing. Okay, for example, somebody at let's say morning 10 o'clock at 5 p.m. from IP 1.2.3.4, they access my page hello.php. Okay, so when they access, we record it. That's all. Now, as soon as we record, it's become history. It won't change. History is history, right? It won't change. Okay, and this is why we use the term log. This is the log or the journal. It is already happened. Okay, but something is there that's keep on changing. For example, right now my web server is using 90%, 99% RAM. They're using 20% of my CPU. But maybe afterwards, after some time, they're using 30% CPU and 89% RAM. Again, they increase, they decrease, they decrease. They keep on doing. They keep on changing. Okay, there's no fixed value. It's like there's no. Maybe there might be history, but it's keep on changing. Okay, so these are the metrics, and metrics, you guys know, we already talk about metrics. Metrics is used to help in tuning, in increasing the performance. So if the client complain, my server is slow and I'm not getting proper response. The first thing the operations guys do, first thing the admin guys do, they always go and check the metrics. What is what might be the cause? Why this low? Because RAM, CPU, hard disk speed, network speed, they go and check. For checking, okay, again, what they need, they also need historical data. Because the client complained 2 minutes ago. So maybe right now they're good, but what happened 2 minutes ago? So we need a data. So again, we also need a data for the metrics. And if we need a data for the metrics, again, we have to store data somewhere in the hard disk. So in both the world, either you go to log, that name normally for analysis or for auditing, and if you go for metrics, that is normally helpful for tuning. Maybe web server is not working good, so I'll change my RAM, change something, or maybe I change my server or network bandwidth. So it's for tuning or for increasing the performance or improving the performance. We need data, but all the use case we need a data, but use case is different. So if you would like to go for metrics, so we have a program who store our data for the metrics. You guys know it's called Prometheus. And for checking, on the real time, or maybe in the historical data, we need some visual tools. And you guys know one of the visual tool we can use is Grafana, but tons of tools also available. Same way for Prometheus, instead of Prometheus, there's a tool called Graphite and InfluxDB. So other tools also available, but we use the combination of this tool who work purely for the metrics. But if you talk about the log, okay, so Prometheus is not good for log storage. So understand one thing, Prometheus is one kind of storage, one kind of database. one kind of storage for you. So if you want to store the log, so understand the one thing, guys, there is a difference between a log and the metrics. Log is normally a file. Log is normally a document. So whenever you would like to store the document, okay, so Prometheus is not meant to store the document, or Prometheus is not meant to store the log. Okay, so we have one more tool that again, like a Prometheus, what Prometheus do, right? Prometheus store the data, okay, or Prometheus is like a database. But if you have a requirement to store the data, there's a log or any kind of document also. It's not only log, other kind of document also. So we have one more tool available in the market called Elasticsearch. So Elasticsearch, you can compare with Prometheus. Again, they are also store the data in the storage. It is also like a database. They store data in the storage. So Elasticsearch is a kind of database like a Prometheus. The only difference is, okay, Prometheus store data that is metrics. Okay, Elasticsearch store data in the database that is a file. That are the documents. Normally, we use Elasticsearch to store the log file, but it is a very flexible kind of tool. You can store any kind of data, even though let's say one example of Wikipedia. So let's one example of Wikipedia. Okay, let's say Linux Wikipedia. So this is also a document, right? This is also a document. You can store this data also in the Elasticsearch. Okay, and one second thing the Prometheus give you, right? Because they store data, because they know where they store and how they store. So they give you one prompt QL for what? For searching, for querying. Similarly, what a document you store, what document kind of file means your data. So what a document you store in the Elasticsearch, they know how they're storing. So they have their own tool or own query language, right, through which we can go and search the data on the document, right? So I will guys discuss in very detail about Elasticsearch, how it works. There are a lot of Intel terminology like indexes and other things, type, and some more advanced thing. Okay, but a very high level, I'm just trying to comparing Elasticsearch. So if you want to store any data, especially in this example, a log file. Okay, so who will store? Elasticsearch. Who will query? Elasticsearch. So you can use this tool for query. But typically this tool is for the database. Okay, this is one thing. But after you store the database, right? After you store the data, like in Prometheus, after you store data, if you want to see it or visual it, okay, Prometheus doesn't have so much beautiful visuals, so we use Grafana to visual it. But Grafana is never a part of Prometheus. Similarly, in the Elasticsearch, okay, if you want to search, again, they don't have a beautiful web UI for search. Even though searching in the Prometheus is a little bit harder because they use some JSON or some kind of command lines, maybe some tool available, but they are not so much simple. Even though Prometheus is a little bit more simpler, but searching in the Elasticsearch is a little bit harder. So we always need some kind of graphical tool who search for us, or maybe the graphical tool who visualize the data for us. Okay, so in the Elasticsearch you can use again Grafana also. So for using the Grafana, we can create a visual, whatever you would like to search, whatever the graph you want to create, you can use a Grafana. But typically with the Elasticsearch, right, rather than use Grafana, there's one more tool that we use a lot with the Elasticsearch called Kibana. It's a very powerful tool, very, very much powerful tool. Even though Grafana is very limited, they are very great in visuals, no doubt, right? Graphs and all the things, but Kibana has tons of more options to do, right? So Kibana is a tool we can use. So what Kibana do? Kibana will go to the Elasticsearch, right, and query to their database, and whatever data they present, they show to the Kibana portal. Or we can Kibana, they can show your data, what did I search, they create graph, visual, dashboard, tons of things we can do. So normally Elasticsearch always normally go for the Kibana because if you think in this way, okay, right now if you talk about Google, let's say Wikipedia, okay, here if you are looking to search something, for example, I'm looking to search, let's say Red Hat, okay, so here I'm not looking for a graph or the visuals. I just want to see some data, some information. Okay, so in this context, you can't use Grafana. Grafana is meant normally for visuals. But if you want to create visuals, but I want to see some information. For example, I have a log. I don't want to see the number of bytes transfers per day basis. Don't create a graph. I don't want to see a total number of IP been transferred. I don't want to see. I just want to see the information. Okay, and I just want to see, can you see me all the data or all the log who have 404 error? Just want to see the some complete data, or maybe sometimes some complete document. Okay, so Kibana will have all the options, what they will show to you. We'll discuss again more, but I'm just very high level again talking about. So that's what, guys, the ELK is. In the ELK, that's what I'm talking about. E is meant for Elastic Search. K is for Kibana, and L is very powerful thing. It's called log stress. So what is log stress? Let me draw one diagram. You will come to know what is the meaning of log stress. So take this example. Let's say you have one web server. It is creating or generating a log. Let's say you have Tomcat server. Again, they're also creating a log. Let's say you have only your Linux operating system. There's no server. They're also creating a log. Okay, and I consider, guys, if those guys who are not comfortable with the log term or the concepts. So on Sunday I took one very basic class. We already shared the link to you. I suggest after the class today, when you get the time, go through it, so you guys will be very much comfortable with log and how the log look like. Plus, we have some cloud. They also create a log. We have some kind of network devices. They also create a log. Okay, so everybody is creating their own log, and I would like to store all the log in one centralized location. So I have one storage. So in this storage, I have one database. Okay, in this database, I would like to store my log. So after I store all the log in one system, that's called my centralized system, I can search it. So for example, if I want like to log only for web server log, I have to go to this system there to see the log there. If I want to see any log about network device, I have to go to that particular device to see the log. But I don't want this. I want some centralized system where if I can keep all the logs in one location, so it will, from here I can search it. So what can I do? Right, I'll send this log to this guy. I'll send log to this guy. I send all log of this to this guy. But the question is, who sent this log to this database? Okay, so who gonna send this log to this guy? So here we have one program. This called log stress. So log stress is a one program who have a capability to go and collect the log, and after collecting the log, send to this guy and store in the centralized system. Okay, and they have again a lot of more capabilities I will discuss in very detail. It's not only to collect, it's called collectors. So they first collect the log and do something on the log. That's called transform. We will discuss what is transform, and there are great use cases we will discuss, and then send this log or push this log to a centralized database. So we can configure a log stress. They have a capability to collect the log from anywhere, almost anywhere. Okay, maybe logstack, we can set up logstack here, and they have a capability to go and collect the log from here. document from here, okay, and sending, and they work on the real time. Because you guys know for my log classes, my log is keep on changing. So as soon as the client is keep on hitting, my log is keep on changing in real time. So Logstash has a capability. What a new log come up again. I don't want to get the complete file again. What a new line, new log, new record, a new event come up. Just collect that part and send to me. And what is transform, we will discuss in upcoming class. But they have a lot of other capabilities also. And after this send to the storage, who will collect here? Okay, so this database can be created by Elasticsearch. So Elasticsearch, right, is the one who store this log sent by Logstash in their database. And after they store, why we store? Because we store this information in centralized system or in centralized database created by Elasticsearch, so we can search it. And now why you want to search again? Same thing. You want to search for analysis, for auditing, for creating graph and multiple things, for monitoring, maybe real time monitoring. We can create. So either you can use Elasticsearch that has its own way to search, or you can integrate this storage or this database to the Kibana. And Kibana gives very beautiful web UI, something like Grafana, but they have more options there because it's not only visual; they do a lot of extra thing also. Okay, for you. So from the Kibana, they give web UI. From there, we can just go and search the thing. Right, we can create a visuals and multiple things we can do with the Kibana. And this tools is three independent tool. It is not like this Kibana you have to use only with Elasticsearch. We can use with other tool also. We can use Elasticsearch to integrate with Grafana also. We can use Elasticsearch independent also. So all the three tools are independent tool. But normally in the real world, we use the combination of these three tool. That's the reason ELK term is become so famous. Elasticsearch, Logstash, and Kibana become so famous. But it is an individual tool. We can use Logstash also independently without using Elasticsearch and Kibana. And Kibana also independent without using Elasticsearch also, right? But we use a combination of this guy because they are they all three together work and do one great magics, right? So that's a very high level description, guys. I will talk more about how Elasticsearch work, what is the data model of the Elasticsearch, what is the Lucene engine behind the scene, what I mean by document, all the things we'll see, Logstash, how to transform and all the things work, and same thing with Kibana. But I just want to tell you very quickly that mainly Elasticsearch will use for log management. But this is not the only use case. Okay, we can use Elasticsearch for multiple. For example, a lot of sites also using Elasticsearch behind the scene for searching. Some site if you go and search, let's say again, let's say Linux. Okay. So a lot of sites behind in the searching engine, local searching engine, they use Elasticsearch for searching. So in the terms of searching capability, they are so powerful. It's very powerful search engine. So Elasticsearch also has search engine. That's the reason they have Elasticsearch. Search is searching engine, right? So we'll talk on those parts. But here my context for using the Elasticsearch is about the log management. And you can compare log management Elasticsearch if you know Splunk. If you know the Splunk. Splunk is again one great competitor of Elasticsearch in the terms of log management. Okay, but in the Splunk, the good thing is they don't have a Kibana. They have their own internal search or internal web UI. They have their own internal storage. They have their own collector Logstash like agent or a universal forwarder there. So very highly, if you know Splunk, you can compare very high level in the terms of log management with the Splunk kind of tool. If you know. Otherwise, we're gonna learn this thing from the very basics. So if you search Elasticsearch, Okay, so this is the website of the Elasticsearch, elastic.co. Okay, so it is based on the Lucene engine, web Lucene, all the thing we gonna discuss. This is the official site of the elastic.co, right? About this thing, right? So what I'm going to do today, I'm not going to discuss more internal part of the Elastic ELK stack. Okay, we are not going to discuss today. I will take one topic in detail. Like say one topic purely on Elasticsearch, one on Kibana, one on one on Logstash. But my plan is to set up this environment. Okay, that's what we are going to do today. Okay, beats are again with different tools. Let's, if we get a chance, we'll talk on the beat. But there's 3 tools: Logstash, Elasticsearch, and Kibana. We are going to discuss today. Okay, so let's start. Let's go and I'll show you how to set up these 3 tools. Okay, again I told you these are the independent tool, but they work together to do something, right? So Elasticsearch for logs and it's for searching. And when you see it, then you can very easily compare with Prometheus and very easily compare with the Grafana also. So you can see, okay, this thing can't be done in the Grafana, that Kibana can do for you, and this thing we can't be doing in the Prometheus, that can be do with Logstash and the Elasticsearch. That's what you can see. So let me directly jump to the setup part and the installation part. So what I'm going to do today, okay, I'm going to install these 3 tools. Okay, but again, depend upon the use case. My use case is to manage the log. When I say log, it means tons of tools and services we have. They are generating the log, and I would like to store all of my log in centralized system. And that centralized system will be managed by Elasticsearch. But who will search? We use Kibana to search. And who will give this log to Elasticsearch? They never go, right? They never go. Okay, they keep on setting idle. So Logstash is the one who collect the log, and that agent Logstash is sometimes also known as collector, right? But they do some more thing extra, and they collect the log and they send this log or push this log to the Elasticsearch. But in the Prometheus world, Prometheus is the one who collect the log, right? Prometheus use the scrapping, they go and collect the log. But Elasticsearch never collect the log. Somebody has to dump the log on the Elasticsearch, right? So, so it is something like this. So let me start to do. So what I'm doing, guys, even though for this you can install three virtual machines to do the things, but I'm not using the 3 virtual machine. We are using Docker or the Kubernetes to do the setup. Okay, so do the things. Even though Elasticsearch also supported distributed computing, so if you got a chance, I'll show you how to create a distributed cluster. So if you have anybody who have done Hadoop cluster, like HDFS, right? So similar kind of clusters we can do for Elasticsearch. Okay, so they were master some data node, and more and more node you have, your performance and power will be increased. So we'll try to create a distributed cluster for the Elasticsearch. But right now, my intention is to just show you to launch one Elasticsearch, one Kibana, and one Logstash and connect together. That's what we are going to do. So for this, because I'm going to do everything in my Docker in this particular system, so this system has don't so much RAM. Okay, so what I'm doing, I'm shutting down this OS and increasing the RAM of this guy. So one thing you notice here, Elasticsearch work on the top of Java. Okay, work on the top of Java, and any application that work on the top of Java normally require some more RAM and CPU. Okay, and similarly Logstash also and Kibana, I think Kibana also, they work on the top of Java. Okay, so all 3 guys work on the top of Java. So they, wherever I launch, I require more RAM and CPU. Okay, so in my case, what I'm doing, Okay, because I'm going to launch all the three guys in the Docker container. So 3 Docker container I'm going to launch in this particular OS. So for this, what I'm doing, I'm just going to setting and increasing my RAM and CPU. So in this OS, I'm going to add 2 CPU. I think 2 might be enough, and I'm increasing my RAM size. I think if you attach, if you give 4 GB RAM also, it might be good. But in my case, I'm giving 8 GB RAM. But if you go to 3 or 4 GB RAM also, that might be enough for this OS. Okay. So let's start. Let me tell you the plan. What is the plan, guys, to create this setup? So my plan is something like this. Okay. First of all, I'm going to create. Let's say this is my base Red Hat system. On the top of Red Hat system, I am running with the Docker. Okay, and on the top of the Docker, I am going to launch 3 operating system. Okay, so this would be my first operating system would be Elasticsearch. Second would be a second operating system called Kibana, and third would be Logstash. Right, and all 3 would be run on the Docker. So I can say obviously container 1, container 2. Okay, so in the Docker world, if you again guys go through my video classes of the Docker, very some day back we have shared with you, and one of the class of my networking, I think in my third session we have shared with you. Okay, there I talked something, right? If one container, okay, would like to connect to second one, container 2 and container 3. So understand one thing, guys, all these 3 container is depend upon each other. Okay, so I want Logstash should have a connectivity to Elasticsearch. Kibana has a connectivity to Elasticsearch. And the Docker world, if you talk about the connectivity, this is a container, right? After my system reboot, my container change. Container change means my IP change. So it is recommended don't provide a connectivity using the IP. Means in the log stack, I will tell what is the IP of my Elasticsearch, or in the Kibana, I will tell what is the IP of my Elasticsearch. So don't provide the IP address. Instead of provide the IP address, use the host name. Using the host name of this Elasticsearch. And it means I want my container 1 can ping to container 2 without using the IP address, with the host name. And in the Docker world, your container name will treat as a host name. When I say host name, it's like www.google.com. So instead of I use the Google IP, we use the Google host name or the domain name. Okay, so normally if you want 2 OS to connect to their ping to their name, we normally need a DNS, but in Docker we don't need a DNS until they have a setup. So my intention is this container I'm going to launch, maybe let's say IP1. So I'll tell my Kibana that container 2 is IP1, but after reboot my IP might change. So we won't use IP. Instead, we'll tell my Kibana, okay, this is a container 2 where you have a database. And if you want to connect, use the container name. Ping to the container name. And the container name will treat as a host. Okay, so every container can ping to each other with the host name. For this, you have to create one box here and put all the guys in one box. And in the Docker world, this box is known as network. So we have to create one extra box or extra network. And if you put all the guys in the same network, then they can ping to each other either with the IP address or with their host name. And their host name is exactly like your container name. That's what we are going to do. So I'm not discussing this part here in detail, why it work, what is the network here, but something like this setup we are going to do. Right. But if you don't know how the network work, why the ping and all the concepts, so I think my YouTube class that I shared with you guys, I think session number class number third, that they are explaining this thing from very basics, multiple examples I showed there. Okay, so that's what I'm going to do. So your choice, either you launch 3 different VM, one for Elastic Stack, one for Kibana, one for Logstack, or we know launching this program on the Docker would be good. And when I said Docker, same setup you can do with Kubernetes also. But I'm not using Kubernetes here. I'm using only pure Docker to do the setup. Okay, so that's what I'm going to do. And for this, obviously, if you're using Docker, you need a Docker image, right? So I'll just go to hub.docker.com. Okay, and by the meantime, let me log into this OS. Very interesting setup actually. All right. Otherwise, you got a lot of RAM and CPU or multiple OS, but Docker make the thing very faster, very simple to manage. Okay, so if you search, first of all, obviously, and both the component, either you go for Kibana or Logstack, I always need first what? Elasticsearch. If you don't have Elasticsearch, how they connect? So that's what I'm doing here. I'll search for Elastic source. It will come up here. So this is the official image of the Elasticsearch, 100 million plus download, and this is the image name. Okay, so I'm downloading this image, but it is always a good practice to check the version. So they have 2 versions available, 7.7 and 8.8, 6.8. So I'm going to download this particular version. Okay, how to download, you guys know. So I'll use this terminal. Okay, let me take the IP, and I'm using PuTTY to connect, because copying from Windows would be simple, right? So I'll use PuTTY to connect. Same OS. So IP 101. I'm going to connect with my root account. Okay. Even though I already saved this IP, I think I have. So let me click directly and open. Okay. By the meantime, let me do one more small thing. Change settings. I don't want they keep on buzz. And okay, so let me start from here. I want this image. So let me download. So Docker pull, and I'm using one of the latest version here. 7.7.1, I think, is the latest version of the Elasticsearch. So that's what I'm doing here. So this image we are downloading. After we download, first, obviously, what we are gonna do, we gonna launch this container. But I want to launch this container inside this box. What is the benefit of this box? One of the benefit is, okay, if we create a network, so network will automatically give connectivity between 2 OS with the host name or with the container name. Okay, so I'm going to create one network here. Okay, and how to connect with network? Let me create one more session here to the same OS. And right now, if you see, guys, this in the Docker, there's a command called Docker network list. So there are some network already created, but I'm going to create one more network. Let's say network called ELK network. You can give any name. So pretty straightforward, right? Only one click, your network has been created. ELK network has been created. Now from onwards, whenever I go into launch, whenever I go to launch any container, right, I will launch in this box, in this network. So I'm going to launch first OS called Elasticsearch from the Elasticsearch image. But one more thing I would like to tell you here is, okay, Elasticsearch is the program. Okay, and every program normally when they work on the network, they should have port number. Okay, and the port number, this program have main program port number is called 9200. This is the byte of a port number for the Elastic search. The port number they use. Okay, so Kibana always contact to this port number. Logstack also always contact this port number. Even though if you directly go to Elasticsearch, we always use this port number to for connectivity. Okay, so obviously what you want anybody from outside world also can connect. And you guys know in the Docker by default we want connect from outside world. We have to expose. So you guys know this command. So I'm going to launch a new operating system. Put in the background, right? The IT. Plus this OS, I'm going to give a name. Let's say my Elasticsearch OS 1. This is my OS name. Or I suggest just give the Elasticsearch as a name. Elasticsearch as a name. Here name is very important. Till today, we have given any name. But in the Docker world, name of the container is also work like a host name. So any other container, they can ping this Docker without knowing the IP with this name. With this name. Okay. Condition is you have to put all the container in same network. So here I already created one network called which network created ELK network. Okay, so give any name, but I use ELK network. This means I am launching one operating system in this box, in this network. Okay, and obviously we will launch operating system with some image. So this is the image we are going to use. So this is still downloading, but I'm going to use this image. But this image will launch always. Inside there they will launch Elasticsearch, and the port number they are using is which port I write 9200. So I'm exposing the same port number. We can change it also. So that's what I am doing here, right? Anything else? Yeah, one more thing we need. In the Elasticsearch, we have options for creating the cluster. And if you remember in the Kubernetes class, I will talk a little bit about the cluster. So normally in the cluster, we have a master and we have a slave node. And slave always connect to the master. So when slave connect to master, okay, that time master should have some port number. So there are two things. One is client. When client connect to master, they normally use different port. And when slave connect to master, they normally use different port. So in the Elasticsearch world, when client connect to the Elasticsearch for what? For searching, right? Or for storing data, they use port number 9200. And when slave connect to master in Elasticsearch, they use 9300 port. So right now I don't have a slave, but maybe in the future we might need a slave. So I'm also exposing one more port here. It's called 9300 port number. But we'll talk about this point in detail when I take dedicated topic on Elasticsearch. I will talk that time. Okay, and that's what has been done. Even though I think document also they have given this command. So they also ask you to create the network. I'm the Docker Hub, and they also ask you to run this OS inside this network. They export this port and they use this image. But here this name is very important. So my next container of Kibana or Logstack, they might don't know the IP of this guy, of this OS, but they will use this name as a host name for connectivity. But right now my intention is to launch a cluster with have only one master. And if you launch only one master, it's called single node cluster. So right now we are launching a single node cluster. We might see a multi-node cluster in the future. So I'm not launching any slave here. So technically, this here everything I'm talking about with respect to Elasticsearch as a tool. And for this, I have to give this option here. My disk type is single node. So that's what I'm giving here. This option. So one click, they will launch the OS for you. My image has been downloaded, guys, successfully. And one more thing I would like to show you here is my current RAM utilization is 4080. Okay, but as soon as I launch this OS, my OS launch. Okay, so around, or maybe keep on, they might keep on, yeah, see here, so much RAM they consume. Okay, so around 1 GB RAM they consume, or more than 1 GB, around 1 GB RAM they consume. Who consume? This OS. Okay, understand one thing, guys. Docker is super fast. One click, the entire OS the launch. But inside the OS, your program is running. It depends how much program consume the RAM. If program consume 2 GB RAM, then you have to provide 2 GB RAM to the Docker. Okay, so this particular Docker, only one OS is running. Okay, this one OS they launched. This is the name we have given, and right now this name is also like your host name of this OS. Okay, it's consuming around 1 GB or some 100 MB RAM. This reason I increase my RAM to the system. Okay, otherwise you see after some time, right? When you run the Docker PS, initially they run, but after some time you see it will fail. It automatically stops. So that time will be very harder for troubleshoot why they stop. But they stop because of you have limited RAM. But I have proper RAM, so it will run for us. And very quicker test if you want to test it is working or not. Okay. So right now my Elasticsearch is working on this particular port number. So I'll go to my browser because I know my IP of my base system. Okay, 101. So I go to my browser. I use my IP address 101 and port number 9200. If you see this message, it means your Elasticsearch is working. And this is the tagline they use, for search. So this tool is very powerful for searching. It is something like somebody also compare sometime with the Google search. Google is also for document searching, right? In the Google, what you search? In the Google, you always search a document. For example, this is a Google. What do you search? For example, I search Linux. Finally, what they search? Whatever they search is a document. This is one document. This is one document. Google is search meant for document searching. So this is a page. This is not page. There is no link. If you click in this link, it open one document for you. So I write some text. And wherever they find this text in any of the document, they search for you. So Elasticsearch will also do the same thing. I'll show you in some example future. So again, it's very powerful search engine. You can think in this way. Google is a search engine for public world. Elasticsearch is a search engine for your company internal world. So all of the company's internal document they normally put and manage in the Elasticsearch and they search using the Elasticsearch. Something like this. You can think also. But here we are going to use Elasticsearch mainly for the log searching or the log management. So this URL you can use to test. This is my if you see the output, which means it's working. But what is the cluster name and ID? We will discuss in the future. But so because in the Elasticsearch we can create a cluster. So every cluster we have to give a name. So this is a by default name they have given, but we can change also. But yeah, main thing is it is working. Okay, so this part is done. So Elasticsearch has been configured. Okay, so next part is how to install Kibana. Okay, so again I'm launching the Kibana also in this particular in this particular box. So we are going to launch Kibana in this particular box. So same thing, Kibana is again one minute. Kibana is also a one different tool, and for this we have the image available. We are going to use that images. Okay, so what I'm going to do here, I'll again go to Docker Hub and search for Kibana. Kibana is there. So it's a tool to index Elasticsearch. Index means, we'll talk more about index, but you can think index is like a database for some time. Okay, and again they have the image for 7.2 version. So again I'm downloading this image, Docker pull Kibana version 7.7.1. Okay, I'm downloading this image. Okay, so again same logic we are going to do, but only the intention, important thing is here is because our intention is to connect Kibana to the Elasticsearch, either to store the data or to read the data, so they can show the visual graph and searching. So for this we need a networking. Okay, and for networking either we use the IP address or the host name. So here we are going to use the host name, and a host name that we give is the container name. But for this you have to put Kibana inside the same network. That's what we are going to do. But by the meantime, Kibana is image downloading. Let me share you one command. So my Elasticsearch is running. I can also curl from command line also. So I can use my IP address. Okay, and port number 9200. So it is working. You can check from here. But one more thing you can check here, right? For example, there's one subdirectory here. We'll talk about this part. It's called cat. Okay, what is cat we will discuss in the future. But if you see here, actually, you know what? By this URL, I connected to your Elasticsearch master or Elasticsearch storage. Okay, and they show you multiple things over here. For example, one of the things they have here called, I think, index. So yeah, this one, index here. Okay, index is here. Or let's say they have one option called master here. So what if I go to master, what happened? Right. Okay, they show you some internal IP address of the master. So they say, I know who is your master. The system who has this IP is your master. So right now, if you talk about the Docker PS, right? If you talk about the IP of this OS, this is one OS, right? IP of this OS or the host of this OS is this one. See here, same name come up. This, so I know who is master. So client can go and check the IP, name of the IP of the master. Even though if you just try to check the IP, you know the Docker inspect command, right? Docker inspect command, and if you inspect this name, okay, it will tell you what is the current IP of your OS. So this is the same IP. So if you have any requirement in the future, you have to see and look for the IP of your master. You can use this. So this and this cat command give you a lot of URL, and this URL is actually known as endpoints. So this is one endpoint that maintain the information about master, and there is endpoint, for example, about nodes. So if you write nodes endpoint here, okay, they show you there's nothing special, but they show you I don't have a node here, right? Why? Because when I go for Elasticsearch cluster, this slave would be a node. Node means how many slaves you have, or it's called data node you have. We'll discuss in the future. So I don't have anything. It's only showing the IP of master. It means right now, your master is working as a master, plus master also working as a slave. The master will help you for searching, and master also giving you a storage for searching or for storing. That is, it is not a single node. One system for both. So this URL you can use to check those things. But and if you go multi-node, you can see multiple IP will come up here of all the slave nodes. But one important URL here or the endpoint here is called indices. Okay, so what it shows you, indices, what it shows you, right now is nothing, right? Nothing is there. Okay, why nothing? Because if you guys know anything about database, any database, okay, let's say if you know about MySQL. In the MySQL, whenever you store data is always stored inside a table. When you create table is always created inside a database. Okay, you might know this, right? Or you can compare with normal operating system. In the normal operating system, database is like a directory, like a folder. Table is like a file, and data is like a data. Okay, but in the Elasticsearch world, this database here is known as index. Table is known as type. Okay, and data is data, obviously. Okay, or data is not data. Actually, data is a document. So we'll discuss in the future about this part and this part. But right now, I just want to tell you, right? Indexes means like a database, like a folder. So whatever data you store in the Elasticsearch, they always first create a database. They first create a folder. I mean, first they create a index. Inside this thing, they store everything. How they store, how they manage, we will discuss in the future. But they manage, or this is the reason they use the term called indices. Indices means multiple indexes. So if they show you all the indexes, whatever they have, I don't have anything because I haven't stored anything in the Elasticsearch. So that is the reason they haven't show you anything. So guys, if you notice also one thing in the Elasticsearch, we don't have any by default any beautiful web UI. So whatever you do in the Elasticsearch, normally you use a curl command, normally. Okay, but yeah, there's some third-party plugins available. Okay, or third-party application available through which we can do the things. For example, one of the plugin name does normally come with your browser. So if you search for one plugin, it's called Chrome Elasticsearch plugin. If you search for this plugin, so there's one Google Chrome plugin available. It gives some beautiful web UI, basic API through which we can you can search something like this. You can search something like this. Okay, so this plugin normally we can use. So in my case, it's already installed, but you can install this plugin into your system. 1 minute, let me share this name. Even though we don't require, because we're going to integrate with the Kibana. From the Kibana we can search. But if you don't want to use Kibana and directly want to connect to the Elasticsearch, you can use this plugin. Just click there, install it. In my case, it is already installed in my Chrome plugin. I just launch this particular plugin, and here you should just give your URL. So in my case, this is the URL where my Elasticsearch is working. So let me copy this URL and let me connect. So finally this connected. So from here also you can search the data. But right now I don't have a data, but when I start storing the data, you can see if you can search from here. So I don't have any indices here. Means I don't have any folders here, database here. Obviously there's no document I have. Okay, but we can directly search. So you can think it is like a PromQ also have their own web UI. You can think in this way. Okay, very limited options you can get, but yeah, if you go to Kibana, tons of different options, very powerful options come up. But let me launch the Kibana. Kibana has been downloaded. Okay, so let me launch the Kibana. Same thing, Docker, run, DIT, put in the background, give some name. I'm just giving Kibana as a name of my OS, but this also name as a working as a as your host name also. Okay, and I'm going to use a image called Kibana 7.7.1 image. But most important thing is which network you are putting. So I'm putting in this guy into the same network. My network name I was used was network. I use is called ELK network. If you don't use the same network, they don't have a connectivity. Even though they don't have, they can't ping to each other. with the name, plus they don't have a connectivity also. So in my Docker class, I explained there, but I put in the network also. Okay, and they also have a port number, right? So you can put the respective port number. Okay, and I believe Kibana work on 5601, right? I think. Let me check the port number. So if you go to Kibana Docker, and normally they give the port number here, which port they are working on. Yeah, so they're working on 5061 port. So I'm also exposing this guy 5601. Okay. Again, they also is given same network already created. I'm putting the same network. Okay. And one interesting thing, they say the guy who created this image, they say, if you use this image already been configured. Okay. Already been configured. As soon as you launch this image, the OS launch, Kibana program launch, and Kibana automatic connect to the Elasticsearch on this port number. Only condition is the host name should be Elasticsearch only. Okay, they say here they will automatically connect to the Elasticsearch instance locally. Okay, so it is there inside the Kibana config file, and that is one of the reason I have given my Elasticsearch name is Elasticsearch. Otherwise, to go to the inside the Kibana config file, I'll show you where it is and change the name there. By default, Kibana, the image, whoever has created this image, they try to ping or connect the container who has this particular name. This is one of the reason I has given this name. Otherwise, I can change. If I change, I have to go to config file of the Kibana and change it. Okay, so guys, launching at the time of launching, get the same image. Also, same container name, Elasticsearch. When you launch Elasticsearch. Okay, so anything else as for this document we need? No. But before I launch, I just wanted to show you one more time again. Free half an amp. My current RAM is very less. Is this one? Okay, 1 minute. Okay, is only this much RAM is left. But guys, I don't know how you know some concept of RAM. So sometime when you run any program, your data load on the RAM, and they store in the RAM in the cache memory of the RAM. Okay, or they also store in the buffer. So this is the total cache in the buffer. Even though maybe most of the program doesn't need this RAM and CPU, but they keep on using unwanted. So if you want to remove all your cache and buffer from the RAM, so if you remove it, obviously RAM become free. If RAM become free, you can utilize from other program. So there's one file in your Linux operating system is called proc. Inside proc sys VM drop cache. So this is one interesting file. In this file, by default value is 0. As soon as you fill the value 3 in this file, this is the way we can fill. What happened? Your unwanted cache and buffer become free. So this is my RAM. They become unused. Whatever the data we don't need. So it is clean, and because clean, now you see unwanted buffer and cache memory of your RAM has been removed, and now you have more RAM free. Okay, so it depends. It's not a good practice always to do the thing, all right? But it depends upon to scenario to scenario you want to clean or not. Otherwise, one thing is you either restart your system, they will clean. Obviously, I don't want to restart. So this other way you can clean your unwanted cache from your RAM. So now I'm more RAM free because I want to launch my Kibana. So right now 4,100 around RAM is free. So let me launch my Kibana. Let's see how much they're consuming. 1 minute. What happened? Sorry, this net is half an net. So one click and they consume not so much. Let's see, not so much, but around 300-400 MB RAM they are consuming. They keep on consuming more. Because Java program always first they load a JVM, on the top of JVM or JRE, they run a program. So it takes some time. Sorry, I cleaned, and they will load it. And Kibana is working on the port number 5601. So again, I go to my system 192.168.5601. Okay, so it is the IP 5601. My IP is what? 5699. 100. So guys, normally Kibana takes some seconds to load. I think my IP is 192.168.901 and 5601. After some time, if you again refresh, it will come up. Don't worry. So they're loading actually. Okay, so they're loading because they are behind the scene what they're doing. They are loading the program. First they launch Java and do the things. Okay, can you hold for a second, please? Yeah, so it automatically come up, right? So they're not ready. They are behind the scene. They are installing, and even though if you keep on checking your RAM, so again they use more than 1 GB RAM, even though running the Docker, but they're using more than 1 GB RAM. After the program has been set up completely, okay, it will come up. Now it is come up. So even the same thing you can see in Jenkins also, right? Jenkins, if you again reboot Jenkins, takes some time to get the applications. So Kibana is loading. Okay, so finally we have according to setup, we have Elasticsearch ready. Kibana is my searching tool or my graphical tool, visual tool. It is ready, like coming up. But I would like to tell you one more thing before I go ahead. Again, let me run my same indices where I run. Let me run my same indices. This one. Okay. Now you see, guys, automatic in my Elasticsearch. Lot of new indices created. Means a lot of new indexes created. And I told you what is index. Index is like a database. Database. You know what I'm trying to tell you here is when you install, when you start Kubernetes, right? They store all their information. All maybe they have some data, their own internal data also, right? They store everything in the Elasticsearch. Kibana is just a program for searching and for visuals, right? But whatever data they have their own internal data, or maybe whatever data you feed in the future, right? They read and get everything from the Elasticsearch. That is the reason, guys. After you that didn't take some time because they connect it to the Elasticsearch and storing data. And how they know Elasticsearch, because it is by default configured. It is there in the this Docker image that they automatically look for the local host 9220 port, and they look for Elasticsearch as a host name. That is the reason they connect and store there. Okay, and then this is the first time you are in your Kibana screen. Just click on explore your own, my own. Okay, and what you see, guys, this is the portal of the Kibana. And notice one thing: Kibana is only not for logs. We can also collect the metrics, and like Grafana, and we can present from here. APM also for application performance. Multiple options. They have huge options, right? If you try to compare it with Grafana, has very their GUI is very beautiful. The Grafana is very meant for their look and feel, view and visuals, right? They're very powerful. But Kibana is powerful in terms of multiple features they have. Okay, and here you can upload the data in some format, data, or here you can connect to Elasticsearch. Okay, so I just click on Elasticsearch here. Even though I'll take one separate class on the Kibana, right? I'm just showing you a very basic thing. Elasticsearch. So they say they won't connect because there's no data in Elasticsearch. Even they have some data, but this data is only for it's some internals of the Kibana, but they don't have any data for document for searching. So are they load somewhere? How? I will use the tech of logstress. So we can take the tech of help of logstress. Logstress will load the data. So I'll just configure logstress. They go and load the data. And what did I load? We can take from the Kibana. Or just for testing, here they give you some sample data set. So here, if you click here, they give you some sample. Let me share this part. Sample data set they give you. Okay, and they have some sample data set. You can load those sample data set for just for testing for e-commerce order, your flight data, your web server log. So you can see guys here, you can see this kind of visual also can we do in the Kibana also, but they will give you more options. Let me show you. Let's say web logs. So I'm just adding one data. It's a sample data, obviously not real data. So I just click on add. So they are getting some data, and after them getting this data, they are because Kibana never stored the data. So technically Kibana behind the scene storing this data on the Elasticsearch database. After they store everything, then they give you beautiful web UI from where you can search and create the graph and all the things you can do. So that's what they are doing here. So they're adding, it takes some time, maybe behind the scene they might be downloading from the internet, and after the download they store in the Elasticsearch. Well, because they're storing the Elasticsearch, so you might also see from here. See, if you see guys here, they create one more database, or you can say they create one more index here. Okay, and in this index they are storing the data. Okay, but if you want to search what data we have in index, so we have option. We can directly give our index name here. So by chance my index name or my database name here, I can give this name. Okay, and if I run this, they show you some of the information. But you want to see the complete data as a search, you can use underscore source. So if you see guys, I'm searching directly from the Elasticsearch. Again, this might be a little bit complex here, right? But but if you search from the Kibana, it's so simple. So they will show you all the data whatever they store. So multiple data that we are storing. So we store some web server logs. You can see some IP here, STL protocol, port number, size. Right? Who stored this data? Just for testing, Kibana store. They store here. Now here, because they store, there's the reason they show you, do you want to view this? So yes, I would like to view. So just show me into the dashboard. So this is the dashboard they show you, and in this dashboard, they show you data. So they will create a graph for you, the visual for you. So a lot of visuals they created. Plus, they also give you some search option here. Or from this search option, you can search it. So multiple query you can write and search. For example, let's say if I add a star here, they search for all the data. Okay, so we'll talk about this dashboard in detail, and multiple query language called KQL language we gonna see. But this is something look like if you ever work on Splunk is called SQL language. So it looks something like this. So we'll discuss, guys. Don't worry if you know the Splunk. If you don't know the Splunk, it doesn't matter. But it is something look like this. Okay, so we can search and do the things. But very high level, I've discussed. So technically, two container has been launched. So let me launch one more OS according to my requirement. Let's call log stress. Okay. So again, I'm going to Docker Hub and searching for log stress. If you see, guys, having Docker makes our life so simple, right? Otherwise, I have to launch multiple operating system and then launch the things take a lot of time. So this is an official image, and again, I'm downloading the same version. So Docker pull log stress 7.7.1. I'm downloading this image, and here again, this is the log collection or data collection engine. We will discuss separately. Multiple things they also do extra thing for you, but these are mainly for this. So there's no command I believe they give you, but it doesn't matter. Okay, so I will launch this log stress here. Okay, but in the log stress, there's no meaning to just launch it, right? You have to first tell the log stress from where you have to collect the log and multiple application file. We have to put in the config file from where, which server we have to collect the log. We have to collect the log from your command line. So multiple things we have to configure the log stress. For this, when I go for log stress, at that time I will explain you. But how to launch it, it's pretty straightforward. Give me 1 minute. I'll just show you. Okay, so it is something like this. So I'm going to run Docker run -dit. Always give the name. So I'm just give the log stress as a name. Okay, and that's all. Then your image name log stress :7.7.1. The most important thing is here you should be in the same network, ELK network. Otherwise you don't have a connectivity, or you are able to ping to the name. Even though this log stress also, the guy who created this image, Intel this image, they write, right? You have to store your data in the Elasticsearch. Elasticsearch IP, we don't know, but we know the name. So in this image, somebody write the name of the name or the location of your Elasticsearch is this one. Okay, is this one. So this is when you should have the same network. Otherwise, you don't have the connectivity and you won't be able to connect with the name. So that's what we are doing here. But some more thing we have to write here, because it's called configuration file. Before that, I have to explain multiple things about log stress, and then we can discuss about the configuration file. But right now I'm just hitting directly here. Okay, but I'm just waiting to download this image, then we will see it. So finally, guys, this is the setup we're gonna use in the upcoming class. So one day I need for Elasticsearch, or one day maybe for complete for Kibana and the log stress. So around 2 days we need to discuss this topic. I'll try to touch as much as we can use. And then we have multiple tools. Then we're gonna integrate this tool with Jenkins and some other tool, depend upon the use case where and what a use case we need. Okay, so that's what we're gonna do. And guys, as per our DevOps assembly line. Okay, there one more class I just want to take in the Jenkins, very advanced class. There I will explain you what is the actual meaning of pipeline. Then after you understand the meaning of pipeline, you come to know the meaning of assembly line. And when you understand the meaning of assembly line and the pipeline, there you see the actual picture of the DevOps. There you understand the right meaning of the DevOps, what is the DevOps culture and what is DevOps methodology. So all this tool, when they work together, you can see that power. Okay, so one class I need for that Jenkins class, and one class I need for Kubernetes plus some more basic thing about Git and GitHub. So this is a high level thing we need, or one class might need for testing, like PyTest, something like that. So 6-7 class around we need more. But depend, if you have more use case, we can discuss. There's no big deal. But this is according to agenda. These are the main things we need. Okay, so I'm just waiting for this guys to download, and then we'll connect this one. So give me 1 minute. Let me get it. So this is a good practical. Even though I suggest to try with the Kubernetes also, because Kubernetes is the same thing. We just click. We just what actually, what happened, my OS paused, right? Why is pause? Normally, if you have a limited hard disk space or the RAM, they post, right? I don't have a space in my C. That is very bad actually. System, most of things won't stop working, right? 1 minute, let me delete something if I don't need. 1 minute. What I don't need. 6, 7 backup. Let me delete this. I might not require. Okay. So let me again start. Click. Actually, it's not stopped. It's been paused. So because of the space. Yep. So I'm just waiting. This thing come up. This is disconnected actually. Or restart. Yeah, one more thing. I also use this thing with the Docker, because same thing you can do with the Kubernetes. The only challenge in the Kubernetes is, not challenge, is good actually. In the Kubernetes, whatever data you store, it is temporary. So you always create a PVC. Means once you have to create a PVC, you guys know how to create a PVC. But to save the time, I create Docker, because Docker is stored in local storage, right? So it save at this training time. That's the reason I use Docker. Otherwise, I highly encourage to use Kubernetes. But initially, obviously, you have to create a PVC to make your data permanent. So taking some time. Again, pause 1 minute. Yeah. So it's been running now. No issues. So let me check again. Restart. So Docker images, checking for image called log stress. Yeah, so the image has been downloaded, I believe, and I'm again launching this image here. For launching, this is my putty, guys. I'm restarting. So when I say restart, it will reconnect to your OS. I don't know why it's taking time to reconnect. Let me go for duplicate. Does my IP change? 1 minute. 101. 1 minute, please. 101. Yep. So I'm running this command of log stress. So they'll launch it, right? So one more OS we have launched log stress. If you guys notice here, I haven't given the port number, because when the log stress, there's some concept of pipeline and some other things we have to create behind the scene. For this, you have to go for some configuration file. So when I go for log stress, I will explain that. But high level, this is the guy who collect the log give and store in the Elasticsearch, and whatever is stored in the Elasticsearch, we can see from the Kibana. Even though without log stack also, we can store the data in the Elasticsearch using Kibana. So Kibana, they show you option there, to upload the data, all the things, but it's not good practice. Depend upon the use case also. But very quickly, I just want to go inside my log stash. The name of this guy is, so I'll go inside. How you go inside? You use the bash. Just want to show you one small thing. So right now I'm here, and this is the configuration folder of the log stash. And if you ls, and this is the main config file of the log stash. So if you want to do multiple things in the log stash conf file of these files, we'll see, right? But if you see this file, what I'm going to show you, the guy who created this image has already configured log stash and say, right, we are going to use Elasticsearch. So again, they haven't used the IP address, they use the name. Because they use the name, it means the system should have pingability, right? So if you try to ping with this name, Elasticsearch, if the ping command is available here, I don't know. So Elasticsearch, yeah, it's pinging, right? So you can see, right, from this content, I can ping to this name. Even though whatever IP would be, I can ping to the name. So this connectivity is possible because of the network. Because of this network. Otherwise, if you don't create this network, this connectivity won't be possible. Otherwise, there's one concept called link. If you guys go through my Linux Docker classes, we can create a link for the connectivity. But if you create an extra network, you will have a connectivity. Okay. So that's all, guys. Today, my very high level plan is to create the setup so we can very easily use in the future classes. Plus, very high level give the discussion, basic overview about Kibana log stash and Elasticsearch. But we'll take this topic separately, the way we do with the Prometheus and the Grafana, and then you conceptually understand what they be doing behind the scene. So that's all for today. Try to do this demo, and we'll do next part tomorrow. Anurag will discuss about shards, and when I go for Elasticsearch, we will discuss about what is shards, right? So we'll discuss everything, all the terminology of Elasticsearch we'll discuss in detail. So like echo3 is just a one Linux command actually. So normally on the running server, if you want to remove the cache or buffer memory of the RAM of the running server, we use this to clean it, depend upon the requirement. Please continue class, don't stop. Yeah, definitely Pankaj, I also want to be continue. So yes, Kranti, I'll definitely try to touch how to create the Kubernetes cluster. I'll try. I'm not able to mount PVC to Prometheus file. Devajit, I told you, even though guys in my last class, I told you in the Prometheus file, you have to find some trick how to make the configuration file permanent. So this was a homework, Devajit. So try some more way. If you're not able to mount it, try some more way. Otherwise, I will give the answer. Vaibhav, Podman, we have already discussed. So guys, from my side, there's one topic called Podman. All right. So I have shared my initial OpenShift video where I given the complete information of Podman. So I discussed how Podman work, why the fast, why the daemonless, how to connect to Runc, what is different with Cryo and Docker. So we have already shared the video. Even not 1-2 classes we have shared about where we cover about the difference of Podman with the Docker plus Cryo plus something OpenShift, right? So Weber, just please go through that link. And this is initially I delivered my OpenShift batch, so that video I have shared with you. And almost everything about Podman or the core about Podman we have discussed there. Let's go through the video. If you think you have some more use case that is not discussed there, let me know. I will also try to take this. Please take one class of Ansible. Yeah, Prashant, I agree. Ansible is very great, but I don't think so. One class would be enough for the Ansible. But I'll try to touch some basic overview if I can take about the Ansible classes. How much RAM we should require for RHEL system? For this demo, I suggest at least your Red Hat VM should have 3 GB around RAM free. 3 GB RAM free you should require for this demo what I'm showing today. Okay, this is reason I suggest don't use the GUI version of Red Hat. Okay, so in my Linux classes I told you guys how to install Red Hat with CLI, so that will save your memory and your CPU. How to create networking Kubernetes? Yes, Lakshman, there is one topic come up where I explained the same concept in the Kubernetes. What I show you today in Docker, I'll show you there. Okay. No, Subhara Salil, I'm not. I never do my training in a hurry. I always be very slowly, calmly. I'll go. Even though whatever the time given to you, we are giving more time. But yeah, everybody has their own, further plans also. So I have to complete my training. Text information. Those guys know the cloud, AWS cloud, any other cloud. They can use the complete practical on the AWS cloud or any other cloud. But yeah, because for this you require instance for more RAM and CPU, so it might cost you something. Can you take the class for dashboard in Splunk? Splunk is one of my favorite topic. I love to, but it take a lot of time, so not possible in this training. Can you discuss namespace and C group? Harshit, which context you're talking about? Because namespace C group we can also we use in Docker, or purely Linux systems also we can use. Concept is same SQL, but different commands we use, right? Which context you're talking about? If you have context with respect to Docker, I will touch. But if you say you have a context for Linux server, won't be possible because it's a very big topic. One dedicated course on this from Red Hat, they cover there in very detail about C group and namespace. We will cover GitLab. It's not so much complex topic. I suggest do the same setup on the top of your Windows. But they have some facility to send the data in the remote system also. There's a different thing. But Logstack is a different use case altogether, right? They will collect the log. They collect. Nobody send them normally by default. They normally collect, and after they collect, they do some kind of transform, filtering, multiple things they do, then they push it. So some of the features look like same, but Logstack has a different use case and RSys log has a different use case.